C3d, reacting masses. So for this we need to look at the relative atomic masses of elements and work out what the relative formula mass, or RFM, of a compound is going to be. So for example, carbon dioxide, a carbon and two oxygens, we're going to have 12 for the relative atomic mass of the carbon, 16 for the oxygen, but because there are two oxygens it's going to be 2 lots of 16, so it's 44 grams per mole. Calcium carbonate, another example, a calcium, a carbon, 3 oxygens gives us an answer of 100 grams per mole. And then more complicated, be careful of brackets, there's 1 calcium and there are 2 oxygens and 2 hydrogens because they're joined together, so it's 40 for the calcium and then 2 lots of 16 for the oxygen and 1 for the hydrogen, so calcium hydroxide is 74 grams per mole. So remember the formula and the triangle, mass divided by relative formula mass gives you the number of moles. And remember that's based on 1 mole is the number of carbon 12 atoms in 12 grams of carbon 12. So here's an example, 6 grams of carbon would be 6 as the mass, 12 is the relative atomic mass of carbon, which will give us half a mole. You also need to know about the conservation of mass and how you can show this using moles. So here we've got a nice straightforward reaction. Calcium carbonate under thermal decomposition will break down into calcium oxide and carbon dioxide. If we start with 10 grams of calcium carbonate, you can be asked how much calcium oxide or carbon dioxide you'll make. Well, the number of moles of calcium carbonate is the mass divided by its relative formula mass, so we have 0.1 moles of calcium carbonate. Now the ratio is 1 of those makes 1 of those and 1 of those, so this 0.1 moles means there's 0.1 moles of calcium oxide made and 0.1 moles of carbon dioxide made. So now if we go back to our triangle, the mass of calcium oxide here is going to be the number of moles multiplied by its relative formula mass. So it's 0.1 moles multiplied by 56, which is the 40 of calcium added to the 16 of oxygen, which will then give us 5.6 grams of calcium oxide. And if we do the same for carbon dioxide, 0.1 times 44, a 12 plus 2 lots of 16, gives us 4.4 grams. And the idea of conservation of mass is proved here because 10 grams will split up into 5.6 and a 4.4, showing another 10 grams made.